Hi, I'm Mr. Franklin, and in this video, we're going to talk about metric conversions, the metric system from a basic standpoint, and in a follow-up video, we'll go into a more advanced version that might be more applicable to chemistry or more advanced physics. So the metric system, or SI, units of measurement, by the time you get to high school, you've heard of it, you've worked with it before, but kind of a review, because we are going to be going deeper with it, is a fundamental quantity is a quantity from which other quantities may be derived. For example, length and time are fundamental quantities from which we get the unit of, or the measurement of, speed. In the metric system, we have a base unit, which is the unit of measurement used to measure a fundamental quantity. And these are decided by a body of scientists that basically come together and decide what actually equates to the measurement of a kilogram, or the unit of length, which is the meter. What distance actually is that? We'll talk about that more in a second. But here is a list of the 7 fundamental quantities from which all other quantities are derived. So we have, first, we got to realize that quantity is a word that means we're going to measure something that means something very specific. And we'll get into these more as we go, but mass has a symbol for m, so that's usually the variable we use, but we measure it in kilograms, and the symbol for kilograms is we have kilo, and then we have grams. And that one's probably the only one that's a little weird in this list. The next one is length, which usually a cursive L if you can handwrite it. Bottom line is we measure it in meters. There's the British spelling of meters. For time, we use the variable for T for time and S for seconds. So seconds is what we measure time in. Current is measured, has the unit of, that's a capital I actually, which is why I prefer to use the capital L for length, so that we're making a distinction between these two. And we measure current with amperes. We will get to that at the end of this year. Temperature is measured in Kelvin. It's not degrees Kelvin, it's just Kelvin, and it's a capital K. Amount of substance is measured in moles. You'll learn all about that in chemistry, and we shortcut it to MOL. What a great shortening. It's short like that so we don't confuse it with the M or the M. So we got meter, we got mass, so we just dropped the E on the end of that one. Luminous intensity, it's I for intensity. And then we have the candela. So in this class, we'll use those. We will talk about this one. We won't use it a whole lot. And that'll be mostly where we spend our time, is in these base units. And we'll spend probably 75% of our time up here, or in derived units. Okay, so let's jump into kind of the meat of what we're going to talk about. And I hope this is familiar to you, but I want to give you some hints and clues to make this go a little faster and to work through it. So when we get into the metric system, one of the great things about the metric system is we decide whatever our base unit is, and we say, if we have multiples of 10 of these, we give it a prefix. So for example, if my base unit is the meter, if I have 10 meters, I could actually use the word deca instead of saying the word 10. So I could say decameter. So if I have 1 decameter, then I have 10 meters. So we use the prefix to represent bigger and bigger, or smaller and smaller numbers of things. So if I use the word kilometer, which we say kilometer in the United States, so kilometer, kilometer, that means literally it's 1,000 meters. So if you travel 1,000 meters, you travel 1 kilometer. Why do we do that? Because kilometers make really big numbers easier to talk about. So that's really the whole reason we're going to use these prefixes. It takes numbers that are difficult to manage and turns them into things that we can measure and work with. So we have kilo, hecta, deca, the base unit, whatever it is, and then we have deci. So when we go below the base unit here with deci, that means fractions. So this is a tenth of a meter. A deci is a tenth of a meter. And then centi would be a hundredth of a meter. So we could have a centimeter. So 1 centimeter is equal to 1/100th of a meter. If I have 100 centimeters, I will actually have 1 meter in length. And we're going to show you this with a specific example in a second. Milli means 1,000. Okay, so millimeter is 1,000. We can also apply these to our other base units. So we can have a milligram. So a milligram is 1,000th of a gram. Okay, it's a fraction, it's a decimal. A milliliter is 1,000th of a liter. We can have milliseconds. We can have milliamps, is actually how we would say it. We can have the milliampere, which means we have 1,000th of an amp. And so all of these prefixes can work with all these: kilometer, kilogram, kiloliter, kilosecond, kiloampere. You'll notice that we will probably rarely use any prefixes with seconds in this class. We will also probably only use kilo, the base unit, centi, and milli for this class, because we'll be keeping it simple. There are actually units, if you watch the follow-on video, where we go beyond those, and you will use those for chemistry for sure. How do I remember this? So this is something you really should just lock in your brain and just know. I learned it way back when, and I still remember it from what I learned back then. And there's a little memory device here. It's called a mnemonic, and it's King Henry died by drinking chocolate milk. You might hear a different word here in the middle, but it's King Henry died by drinking chocolate milk. So king for kilo, Henry for hecta, died for deca, by for the base unit. Okay. Some people use while or something else, but it stands for one of these. So the meter actually goes here. That's the base unit, or the gram. Okay, so the base unit goes there. King Henry died by drinking chocolate milk, which later, when you're working on a problem by yourself, you can just write King Henry died by drinking chocolate milk. Some people write it horizontally, and some people write it just vertically. I prefer the staircase because I get less confused when it becomes time to do a conversion. So there's a reason I write it at an angle. And so I would say until you get more familiar with what's going on, you should do the same. How is this going to work? So when we're doing a metric conversion, basically we've measured in one unit, but we actually need to work in a different unit. So for example, when we get into the classroom, the scale that I have only measures in grams. But to get an actual force in newtons, we have to convert it to kilograms to do our calculation correctly. Okay, so we measure something in one scale, but then we have to convert it so we can use it in a different scale. That's the simple version of this. Now, when we do this, when we do a conversion, the object has an objective measurement. So for example, the length and width of my phone, I could measure this in meters. I could measure this in kilometers. I could measure this in centimeters. Does it actually changing the unit of measurement, does that change how big the phone is? No, it does not. Okay, so we're changing the units, but we're not actually changing the objective measurement, the objective reality of what that measurement is representing. Okay, so that's important to understand. So this remains unchanged even though I'm changing the scale of the measurement. So let's take a look at one. So a meter. So if you outstretch your arms, that's, depending on how long your arms are, that's still probably going to be pretty close to the size of a meter. Okay, so that's a meter. If you look at a meter stick, you will notice a lot of little bitty lines, and those represent centimeters and millimeters. Okay, and there's a bunch of them. So if we're down here at the bottom of the ladder, it's going to take a bunch of those to equal this bigger measurement. So these are bigger measurements, smaller measurements. But the meter itself cannot actually change how big it physically is. We're just going to change the size of the number we're talking about. Okay, so let's do one. So 1 meter, let's find out how many centimeters it is. Now, As we go down the ladder here, we're going to go down 1 and we're going to go down 2. Each step is a factor of 10. So we're either multiplying or dividing by a factor of 10. So as we go down and to the right, we're going to multiply times 10, but we're going to go down 1, 2 steps. So we're going to go 10 times 10, which is 100. If we multiply 100 times this number that we have here, we will get how big the number is in centimeters. So it happens to be 100 centimeters. Let's do millimeters. If I go to millimeters, go decimeters, centimeters, milli, 10 times 10 times 10. So that's 100 times another 10 would be 1,000. So 1 times 1,000 is 1,000 millimeters. So why is the number getting bigger when we said earlier that by definition a millimeter is 1,000th? How come the number is getting bigger? Okay, well, that's because this is the distance. So if the millimeter is 1,000th of this, how many little 1,000ths does it take to make up something big? It's going to take 1,000 of those little bitty markings to make up something that would be a meter long. As we get to the smaller scale, the numbers will actually get bigger. So it's on an inverse here. So let's take a look at a kilometer, and maybe that'll help make sense. So a meter, that's not very big when we're talking kilometers, because 1.6 kilometers is almost 1 mile. Okay, so kind of keep that in your mind here for us in the US. We're going to take a meter and turn it into kilometers. So we should get a tiny number if we're using our brain, common sense. So let's find out. So base unit of meter, deca, hecta, and kilo. So as we go to the left and up, we're actually going to divide by 10. Okay. So we're going to divide this 1 by 10. So if I divide 1 by 10, I get 1/10, right? Which is 0.1. Well, that's the first step, but I got to go a second step. So what's 0.1 divided by 10? If you plug it in your calculator, it's 0.01. If I divide that by 10 again, I'm going to get 0.001. Okay, so notice this is 0.001 kilometers. 1,000th of a kilometer is equal to that distance because it's a meter. Okay, so if we have our meter, that's 1,000th of a kilometer. I'm going to clear the board here, and I'm actually going to show you a shortcut. You need to know that you're actually multiplying and dividing by factors of 10 each time, but here's the shortcut. If I have a meter and I'm going to centimeters, I go 1, 2 steps down, which means I'm multiplying times 10. So the number should get bigger, but I'm going to take the decimal and I'm going to go 1, 2 steps. And I went to the right. Why did I go to the right? Because it's going to the right. As I look at my screen, my little staircase here went to the right, so my decimal is going to go to the right. Okay, so 100 centimeters. Okay, so let's take a look at millimeters. Base unit, 1, 2, 3. So I'm going to move the decimal to the right 3 times. 1, 2, 3. So when we move down, the result is going to get bigger, and we're going to move the decimal to the right. So it's why I do it on a diagonal. So I know which way to move the decimal, but I also understand, should my number look bigger or smaller? Okay, let's take a look at one where we go the opposite direction. So let's take a look at 1 millimeter. So we're looking at like the width of a paperclip, something really, really tiny. What is that in centimeters? So I'm just going to use the shortcut, but know that every time I go to the left, I'm actually dividing by 10. But I move 1 step to the left. So I'm going to take my decimal and I'm going to move it 1 step to the left. So that becomes 0.1 centimeters. So 1/10 of a centimeter is equal to 1 millimeter. All right, let's keep going. Centimeter to meter, 1, 2, 3. So I'm gonna move my decimal, 1, 2, 3. Fill in any holes with zeros and put your decimal. So I have 0.001 meters is equal to 1 millimeter. Okay, so got to remember, we're not changing the width of our paper clip. It's still 1 millimeter wide, but in terms of meters, that's 1,000th of a meter. It's tiny, tiny, tiny. Okay. If I had to work in kilometers and I had to go all the way, it would be, so millimeters, 1, 2, 3, 4, 5, 6. So I'm going to take my decimal and go 1, 2, 3, 4, 5, 6. Fill in the holes with zeros. Know that each step you're actually dividing by a factor of 10, and that would be kilometers. So now we got to write that number clean so that we, and usually when I have a decimal, I usually put a 0 in front of the decimal to tell me there's a decimal there. Okay, 0, 0. How many zeros do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's what you got to be careful of doing this, is making sure you have the right number of decimal places and zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, looks good. So that's in kilometers. And you should never leave the number without the units. So a paperclip is really, 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 really tiny, okay, in terms of kilometers. So that should make sense. So notice we're not changing the size of the object. We're changing what kind of numbers we're talking about. Okay, we're going to try a couple. You're going to try it, then I'm going to show you the answer, and then you will be able to go to your work. So go ahead, try this one on your own, pause it, try it on your own. All right, welcome back. Let's check and see what you got. So 24.78 meters. So meters is my base unit, and I'm going to milli. So 1, 2, 3, and I'm moving to the right. So I'm going to go 1, 2, 3. So 24, 7, 8, fill in any holes. So 24,780 millimeters. Does that make sense? If I have 24 meters, 25 yards, 24 meters, okay, should I have a ton of really baby units, millimeters? Does that make sense? So I move the decimal to the right and my number gets bigger as I go down the ladder, down the pyramid. Here's another one. So I didn't change the number, but you're going to go a different direction. So go ahead and try this on your own. Pause it. All right, welcome back. Let's take a look. So this time we have 24.78 meters. So meters is my base unit. That's where I'm starting. And then kilometers. So 1, 2, 3. So I went to the left. So I'm going to go to the left. So I find my decimal, which is here in the middle, and I'm going to go 1, 2, 3. So 0.0247 kilometers. Okay. And that would be sound about right. So 24 meters is not very much in terms of kilometers. It is 2/100th of a kilometer. Okay, we're going to try one more, but this time I'm not going to give you the ladder. You're going to have to take a look at your notes and do it from there. So just notice that I switched the base unit. We're not using meters. We're using grams this time. It shouldn't make a difference. Okay, it's the grams is the base unit. So go ahead and pause it and try this one. All right, welcome back. Let's check our answers. So the first thing I do when I get a problem, and even though I'm pretty good at this, I still tend to, out of habit, sketch this chart very quickly, because when I don't and I go too fast, I usually make a mistake. So KHDBDCM, King Henry died by drinking chocolate milk. All right, so I've got kilograms. So notice I often circle the one, what I'm at. Where am I going? I'm going all the way to milli. 1, 2, 3, 4, 5, 6. So I moved the decimal to the right. So I'm going to move the decimal to the right. 1, 2, 3, 4, 5, 6. So that's going to be 25. And then 1, 2, 3 zeros, so 25,000 milligrams. So 0.025 kilograms is equal to 25,000 milligrams. And that makes sense because it takes a lot of little bitty things to equal something much bigger. Last one. Pause it, try it on your own, and then you can come back and check your answer. All right. King Henry died by drinking chocolate milk. So this one, 0.4 millimeters. So I'm here at millimeters and I'm going to kilometers. 1, 2, 3, 4, 5, 6. So I move to the left. So the decimal's here. So 1, 2, 3, 4, 5. Oh, really tiny number. 0.0, 0, 0, 0, 0, 0, 4. So let's count places here. I got the 4. There's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and a decimal. And I tend to put a 0 in front of the decimal. So that is in kilometers. Don't forget your units when you're doing this. Okay. Now, last thing before I turn you loose on your practice problems, you'll notice that these numbers get ridiculously long, and that's why usually we actually tend to jump into scientific notation shortly after, but we need to practice this first, and then once we get a good foundation, we will take a look at scientific notation. All right, that's all I've got. You've got some homework assigned. Good luck practicing. Make sure that you let me know if you have any questions. Hi, I'm Mr. Franklin, and this is part 2. This is an advanced metric conversions. So if you want to know more about how the metric system is kind of put together, you can see my previous video. But in this video, we're going to go to the extreme ends of the metric system and take a look at how to do basic conversions with them. Usually you will need this in chemistry for doing energy of light, frequency of light, converting nanometers to meters, using the speed of light, those kinds of things. You can also see this in physics when we get into particle physics and extreme speeds, those kinds of things. So yeah, so let's take a look. So, wow, we have our base tower here, our base ladder here. We have King Henry died while drinking chocolate milk, right here in the middle. King Henry died by drinking chocolate milk. But then we have our extreme end. So on this end, we actually have what's probably most familiar. We have exa, peta, tera, giga, mega. So kilobytes, megabytes, gigabytes, terabytes, right? Okay. So we have peta and exa at the large end of things. Okay. On the smaller end of things, we have deci, centi, milli. Then we have micro, nano, pico, femto, and atto. Now, when we're in our ladder here, each step is separated by a factor of 10. We're either multiplying or dividing by 10. So times 10, times 10, times 10, or divide by 10, divide by 10, divide by 10. However, when I go from kilo to mega, we should all remember that a megabyte is 1,000 kilobytes. So there's 1, 2, 3 steps to mega, okay? From mega to giga, there's 3 more steps. It's 1,000. 1, 2, 3. Let me change my color here. So 1, 2, 3, and then giga to tera. 1, 2, 3. Tera to peta. 1, 2, 3. And peta to exa. 1, 2, 3. So when we get into these, we're going to be multiplying by factors of 1,000, or moving the squiggly, moving our decimal 3 places. Same down here, milli to micro is 3. So 1, 2, 3 to micro, 1, 2, 3 to nano, 1, 2, 3 to pico, 1, 2, 3 to femto, and 1, 2, 3 to atto. Now, most likely you will find this memory device called a mnemonic for King Henry died by drinking chocolate milk for the center. I always had a problem when I started getting into this, keeping which one goes where. And so I came up with one of my own for the rest of it. So every person thinks George made King Henry die by drinking chocolate milk, missing no pinkies Friday afternoon. Which is crazy because I remember that, and I remember the order and I don't have to think about it very hard. Seems weird that I'm actually memorizing more information than just memorizing it, but it helps me. Now, generally in chemistry, you only deal with this end. And this and kilo, okay? It's really only in physics that we tend to get up here because we're dealing with extreme ends of things. So when we start talking about galaxies and all that kind of stuff, we could be talking about these things. Down here, we're talking about the atom and very, very tiny things. So let's take a look at what this looks like for a unit conversion. So let's try one, 0.25 grams to micrograms. So this micro is the Greek letter mu. So it's basically an M, but it's got a little U-like tail to it. So when I get this, first thing I go is it's on the small end. So I only write King Henry died by drinking chocolate milk. Mu, micro, nano, missing no pinkies, Friday afternoon. So I'm going from grams, my base unit, and I'm going to micro. So that's 1, 2, 3, and then 3 more, 4, 5, 6. Okay, so when we go from milli to the next one, it's 3 steps. So 1, 2, 3, 4, 5, 6 to micro. So I'm gonna move my decimal 6 places. And we're going to the right, so let's do that. 1, 2, 3, 4, 5, 6. So that's 25 and then 3 zeros. 1, 2, 3. 25,000 micrograms, which that's hard to type. So generally, if you're dealing with that, I would prefer to write it. You just make like a U, like a cursive U, and then you put a little tail on it, on the leading edge of it. And that's micro. And I always do mine on the wrong side, just saying. So anyway, 25,000 micrograms is equal to 0.025 grams. All right, let's take a look at another one. This one is one you will do in chemistry or could potentially do in chemistry because you'll look at a beam of light and you'll see its spectrum and you can read what the wavelength of red light is. We actually might do this in our class as well. And the wavelength of red light is 450 nanometers. Okay, so that's nanometers. But when we're dealing with the speed of light is in meters per second. So we can't do math with nanometers and meters per second. We got to pick one. So generally, I tend to pick meters, okay? Because most everything we do will be in meters and it'll just make your life easier. We're still dealing with the small end of things. So King Henry died by drinking chocolate milk, missing no pinkies, Friday afternoon. So we're starting at nano, and now we're going to meters. So we're going to go 1, 2, 3 to micro, 1, 2, 3 to milli, and then centi, deci, and then meter, our base unit. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Nano literally means 9. Okay, so we're going to be dividing by 10 by 9 times, or move the decimal 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I fill in all those with zeros. So 0, 1, 2, 3, 4, 5, 6, and then 4, 5. Okay, and that would be in meters. This is really where we should be getting into scientific notation because I don't like the way that looks. We would convert it to scientific notation, and if you know some exponent rules with your math, it actually makes the future math much easier, and hopefully I'll get to show you that as well. All right, let's take a look at another one. Go ahead and pause it and try this one on your own and see what you come up with. All right, welcome back. Let's take a look. A little tricky this time, went to the other end of the scale here. So guess what? King Henry died while drinking chocolate milk. And then we got every person thinks George made King Henry. So we've got tera, and we're starting at meter. We're starting at the base unit. Oh my goodness. So that's going to be a lot of zeros. 1, 2, 3. Yeah, that was horrible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, 12 decimal places. And we're going to the left, so we got to move our decimal to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And usually if I run into the problem I was kind of running into there where the typed numbers are too small for me to move my pencil, I will actually rewrite the whole number and do it because I do not like making mistakes. 1, 2, 3, 4 zeros. Even though I do all the time. 1, 2, 3, 7, 8, 7, 9, 1. Tera meters. Okay. Super, 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 super tiny. Okay. Even though 12,378,791 meters is a lot of meters, in tera meters, it's pretty small. So that's the basics of it. Generally in this class and most science classes, you will do kilo, and that's about where we stop. If we go beyond kilo, we're probably jumping into a completely different set of units, like astronomical units, light year, things like that, because they're even bigger than some of these others. So when we talk about energy, you might see exa and peta. When we're talking computers, you'll definitely see that. Petaflops has to do with how many operations a second, which is not the same as processor speed. So we do use it for other things as well, but mostly in the sciences, you will deal with the smaller end of things. All right, so there are some exercise problems for you to work on with these as well. So have at it. Let me know if you have any questions. Thanks. Bye.